let's try a little bit of a more complex balancing equation problem. So as you can see, this one's quite a bit more complex than our hydrogen and oxygen combining to make water. You can see we have a lot more stuff going on, and so I'm gonna show you some steps to be able to solve balancing equation problems. Now, there's no really for sure tried and tested method of balancing chemical equations, but I'll show you some useful tips anyway to help you out with these. And the first thing I'm going to do, and I'm going to kind of solve this, it's going to take a while, but I'm going to solve this kind of the long way. And if you kind of stick to this method, you should be able to balance any equation that you come across in your chemistry class. So what I'm going to do first is I'm going to split this equation up into the product side and the reactant side, and then I'm going to list everything that I have, all the different elements in these two sides. I have the same elements, but then I'm also going to list the amounts of each of those elements. And so if I look here on the reactant side, I can see I have 2 irons. So I'm going to list that, 2 irons. I can see I just have the 1 potassium over here. So I have 1 potassium. When I get to sulfur, though, you can see that I have this sulfur right here in parentheses, and I can see there's a 3 outside that parentheses. You see that subscript 3. And what that 3 is telling me to do is it's telling me to multiply everything inside of those parentheses by 3. And so since I only have 1 sulfur there to begin with, if I multiply that by 3, I'm going to end up with 3 sulfurs. Now oxygen works the same way. Inside the parentheses you can see I have 4 oxygens, and so I'm going to take that and multiply that by 3. 4 times 3 is 12, so I have 12 oxygens there. But I missed something. You may have caught that. My 12 oxygens are there in the sulfate ion, but then I also have 1 over here in the hydroxide, and so I need to add that. So let me make that change here really quick, and so I'll change this to a 3 to add that extra oxygen in there. And then lastly, I can see that hydrogen, I just have the 1 hydrogen. Alright, so there's my reactant side. Let's take a look over here at our product side. So I can look and see I just have the 1 iron, and I have 2 potassiums right there. And then my sulfurs, I just have 1 sulfur. You can see it right there, just 1 sulfur. And then oxygens, I can see again, are split up in 2 places. I have some of the oxygen over here in the sulfate, some of the oxygen over here in the hydroxide. And so I have 4 oxygens plus 3 oxygens. You can see how this subscript 3 again multiplies everything inside the parentheses by 3. And so I have 3 oxygens plus 4 oxygens gives me 7 oxygens there. And then likewise I have my hydrogen in those parentheses, and so I have just the 1 hydrogen in parentheses times 3, so I have 3 hydrogens. Now as you can see, nothing in this is balanced right now. I don't have anything that's actually balanced. So it looks like I have a lot of work ahead of me, but I'm going to give you some steps that should help you with any balancing equation problem. Here's the steps I'm going to give you. They work really well if you stick to them and follow them and kind of list everything like I've done here, especially with those larger problems like we have here. So, step number 1 is first balance the metals. Alright, so always start by trying to balance the metals first. Step number 2, once the metals are balanced, then you can try to balance the nonmetals. And step number 3, this is the most important one, leave hydrogen and oxygen until the end. The reason we leave hydrogen and oxygen until the end is because usually they're going to balance themselves out if you've balanced everything else correctly. Alright, so let's try to work through these steps. I'm going to start with the metals to start off. Alright, so I have two metals. I have iron and I have potassium. Let's just start with iron here, since it's the first one that we see. And so right now I have two irons on my reactant side, and I have one iron on my product side. So let's see what we can do to balance this out. Now, what I can do in order to balance an equation is I can add coefficients. Alright, so in front of any of these formulas, I can put a number there. We call that a coefficient, which is going to work kind of like these subscripts. Okay, but if I put a number here, in front of a formula, it's going to multiply that whole formula by that number. Now I cannot change these subscripts. Those are permanent. There's nothing I can do with those. I can only add subscripts. Now if you are solving a bunch of these problems on a worksheet or doing your homework, I highly recommend using pencil, because you're going to be changing these numbers a lot. The coefficients we start putting down are probably not going to stay that way. We're probably going to change them a couple times as we work through balancing this. So let's go ahead and start by trying to balance iron. Okay, the first thing I'm going to do is add a 2 in front of my iron hydroxide. All right, that's going to multiply everything there by 2. All right, so it's going to multiply all of this stuff by 2, and so it's not only just going to change the amount of iron, it's also, you can probably see, it's going to change the amount of oxygen and hydrogen. But let's just start with iron and see what happens. First of all, I only had one iron to start with, so I multiplied that by 2, and now I have 2 irons here on the product side. And actually, let me get rid of that and just put a 2 like that. Alright, so now I can see that my irons are balanced. And so following my steps, those 3 steps I gave you, I'm going to keep on moving through my list here, and I'm going to move to the next metal. So potassium is the only other metal I have, and I can see that I have 2 potassiums on the product side and only 1 potassium on the reactant side. And so I'm going to put a coefficient here. I'm going to put the coefficient 2. So I'm going to multiply everything there by 2, and that's going to change the number of potassiums I have on the reactant side to 2, and you can see that now my potassiums are balanced. Alright, now moving through, now that my metals are balanced, I'm going to move through those steps, and now I'm going to work on the non-metals. So I can see I have sulfur there, and so I can see on my reactant side I have 3 sulfurs, on my product side I have 1 sulfur, and so I'm going to put the coefficient of 3 in front of my potassium sulfate, and that's going to multiply everything there by 3. It's going to multiply my sulfur by 3, and so I'm going to change over here the amount of sulfurs I have to 3. Okay, but you can see it's also going to change the amount of potassiums I have, and I just made that change, and so now I have 6 potassiums. Now don't worry about that, because we'll go back up to the metals, go back to step 1 here, but let's just continue on and see what else we changed. We also changed the amount of oxygens. So you can see now we had 4 oxygens here, and we multiply that 4 by 3, and so now I end up with 12 oxygens over there, plus I have my 6 oxygens over here on this side, so that's going to change the number of oxygens I have on my product side to 18. All right, now that's all the changes we've just made there. Now let's not worry about the changes that just happened with our oxygen. All right, remember, we're going to leave that to the end, but at least I have my sulfur balanced at this point. So let's go back up to our potassium here. You can see that my potassium is not balanced anymore. So I'm going to make a change here. And I can see I have 6 potassiums over on my product side. Okay, so I have the 3 times 2. And I only have 2 on the reactant side. So let's go ahead and change this to, I'm going to change that to a 6, right? Because 1 potassium times 6 potassiums, that's going to give us 6 potassiums over here. So I'm going to change this number to 6, and now I'm okay with my potassiums. So let's just quickly check our metals. Our metals are balanced, right? So the ions are 2 and 2, so those ones are good. Our potassiums are balanced, 6 and 6. And then we'll check our nonmetals. Our sulfur is also balanced. All right, in the meantime, when I added this 6, however, right, so when I added that 6 right there, I've only accounted for that potassium so far, but I've also changed the amount of oxygen I have on this side. So let's take a look at what happened there. Now, I had 12 oxygens right here, plus now I have 6 oxygens right here. So 6 plus 12, you can see that we've changed the amount of oxygens on this side to 18. And as you can see, look what happened. Our oxygens have balanced themselves out, and that's why we always leave those oxygens and hydrogens until the end. Let's see if the same thing happened here with hydrogen. And actually, I missed something back here a little ways. When I put this 2 over here in front of that iron hydroxide, I forgot to look at my hydrogen because that changed. I left it at 3 down here. You may have caught that. And so I did have 3 hydrogens to start with, and since I put that 2 in front there, I need to change this 3 to a 6. So I really have 6. Now, if you've kind of been looking ahead here, you can see here's my 1 hydrogen on my reactant side in that potassium hydroxide. I'm going to multiply that by 6. You can see I'm going to change this 1 to a 6. And again, you can see why we leave those hydrogens and oxygens until the end, because they have balanced themselves out. So just to quickly recap here, those steps, you can see our final answer here up at the top. That's what I would write down as my final answer. I would just put those coefficients in there. And so those are the coefficients that make this thing balanced. Here's my steps. So if you follow these steps, you should be able to balance any chemical equation. First step, start with the metals. Get the metals to balance first. Second step, move on to those nonmetals. And then third step, leave hydrogen and oxygen until the end, because usually they're going to balance themselves out.